Hi, and welcome to Module 8.1. In this module, we're going to be talking about infrastructure and operations. We're going to do a little bit of a twist, a little deviation from the book. I'm going to give you a couple of different insights into how we can approach management of infrastructure resources, how we can basically move hardware in from one department like development to quality assurance to production as much as possible in order to save money and not have over-ending costs and keep our data center as efficient as possible. So the first slide here basically just shows a focus on how the breakdown of budget has occurred within various industries. And as you can see, IT services in general here, about 10% for a little bit more than 10% for banking and financial services, and that's kind of what would be expected. Hardware and software, again, as percentage, R&D, salaries are always the largest chunk within an IT breakdown. And what this basically shows is where the focus is. You would see generally hardware kind of reducing. This is in 2006. If we were to draw a chart or find a chart for a period of time, you would see these hardware costs have dropped, that the budgets have dropped for hardware services as well. It's interesting. I'm not really sure where networking fits in here. I would assume that it's in hardware, but because I'm not sure how the chart was made, that it is. I can only assume that it would be in hardware there. So why talk about operations? Well, effective management of IT operations basically means we can hold the best practices. We have our equipment running at the optimal levels so that the applications that are running on them are performing the way they're expected. We want to be able to roll applications out, perform maintenance. And we're talking about patches on software or mostly operating systems. Networking, we want to make sure that we have our network tuned so that we have enough bandwidth to handle all the application requests. But the thing with IT operations is it involves all stakeholders in IT-related operations. Now that means that your architects have to get involved. That means that your application developers have to get involved. Even business analysts, people who act as liaisons between the business and IT, need to understand what's going on within IT operations. And IT generally, from an operations perspective, has to adopt a partnership perspective. They have to focus on the fact that they don't just have to have the hardware or the server up and running. That the server represents a tool that a business uses to drive value in the organization. And so they have to be in partnership with the business to understand what that server means to the business, or what the network means to the business, or what the overall storage and the database mean to the business, that there is some inherent value. So the typical IS budget, and we just put a pie chart here, just to basically show that, administration and planning is a significant chunk. Maintenance is usually the smallest chunk. Now that's not that bad. The reason it's not that bad is because if you think about it, you want to try and keep your maintenance costs constant and fairly low in relation to the other things, because maintenance doesn't necessarily add value. It keeps value in the business. New applications, new equipment, those might add more value, but we can't neglect maintenance. We can't have this slice here as being so thin. So we need to be cognizant of how this chart looks. Pieces of the pie that are too small are not good. And if they're too big in certain areas, then that's not good either. If we're spending 50% of our budget on maintenance, that could be a big problem, or at least it's a symptom of a larger problem. So how do we solve these operational problems? We take a portfolio approach. Some of the typical problems you might find are slow response times, the network is down, data is unavailable, or applications are unresponsive. Well, the traditional way to respond to these things, especially if there's a slowdown in an application response time, would be people would buy more equipment. And maybe that's the right approach, maybe it's not. But you have to understand when it is the right approach and when it is not. Regulate and prioritize computer workload and activities. Now this is interesting because this would be more tuned to, or people would be more tuned to this in the mainframe where you allocate certain times on processors. As we went into multiple server approaches, you basically could have the whole server to yourself for a particular application. But now that we're going back into virtualization, we need to be cognizant of how much resources we would actually allot to a particular server. So we do need to understand the priority by which certain things run. Even more so is important as we get to large data warehouses. Certain processes that run to pull the data and cleanse the data are more process intensive and are more valuable. And so therefore those may need to run first. So those might actually be given priority. So it's this balancing approach that we need to understand, and it's really based on the application and the value that the application brings to the business. And ultimately we have to bring operational measurements. We have to set a standard by which we are going to follow. And that means that a performance on a server should be in terms of milliseconds or transactions per second, number of transactions per second. It could also be that our network is tuned to such a way that we are only using 60% bandwidth, or that the database never reaches 80% CPU utilization. Our storage is always below 80% storage capacity. Those are the benchmarks that we will set and then we will monitor against them on a regular basis. So we introduced the notion of an infrastructure lifecycle. If we were going to implement a new system, we would say, okay, we might need to buy additional hardware. But if we buy additional hardware in production, we'd also have to consider buying similar or the same hardware for quality assurance. Because if you're running tests, and there are two types of tests, functional tests and non-functional tests. The non-functional tests are, how is it performing? Those are beyond the functions of the application. So if we're running non-functional tests like performance, it has to run on a very, very similar box, if not the same box. Development might have to run on a similar box, but not necessarily as powerful. Because when you're writing code, there may be certain things that are specific to the chipset on that server. So if we're going to buy all this equipment, I've just basically gave you 3 separate environments for a single system. That could get expensive. So we have this notion of an infrastructure lifecycle that says, when do we move equipment out of production, possibly into QA, and then say we can use it for development? And if we use an infrastructure lifecycle that says we would implement the best technology in production, slightly less in quality assurance, slightly less in development, we would basically be able to have easier management of components because we can assure similarity between the components. We can reduce complexity because they generally should be the same with slight deviations. We should have easier integration between the various systems because they would generally be the same. Ensure service levels are running at optimal levels. This way we can guarantee that our production is running the way it's supposed to. And reduce our overall maintenance and acquisition costs because we're not buying new equipment necessarily all the time. We are repurposing slightly older equipment without compromising quality, which is one of the fundamental things. So the way you do this is you conduct a technical architecture and inventory review. You establish various service levels and metrics for each different environment, which means production has to have service levels and metrics, quality assurance, and even development. And then you implement a rotation strategy, whereby we say that the server in production will last 2 years, and once it lasts 2 years, we will move it into quality assurance because the hardware architecture is the same, and we will buy a new upgraded version of that equipment, trying to keep certain things the same, like operating system levels or database, things that are application or OS levels. And then provide a cost analysis of our infrastructure. Are we managing the return on the investment that we have? Is it applicable to what we need, or do we need to consider a complete change?